Hello everyone, so I'm Rahul Kaushik and I welcome you all on my channel Tivvra. तो देखिए आज का बहुत इंपॉर्टेंट टॉपिक मैं लेने वाला हूँ हार्ड एंड सॉफ्ट वाटर. पॉइंट इज नाउ व्हाट इज हार्ड वाटर, व्हाट इज सॉफ्ट वाटर, हाउ विल यू आइडेंटिफाई दैट, एंड वन मोस्ट इंपॉर्टेंट पॉइंट ऑफ today's discussion is this is very important question. Very important concept, and question over this concept is frequently asked whether it is IIT JEE Mains Advanced or it is NEET or some other competitive exam. So you must know about hard water, soft water, what is hard water, and how you can make that water hard, how you can identify that water is hard. I'm going to tell you each and every point today, right? So before I start today's class, let me introduce you. I'm Rahul Kaushik. I worked in Bansa classes Kota for continuous 10 years. And during my tenure there, I mentored 2000 plus IITs with 10 plus years of experience in Bansa classes Kota, and now I'm here to share all my experience and knowledge with you. So the point number one is, what is hard water? We see in our day-to-day life daily what is water. So what is hard water? So let me tell you, you might have seen your mom boiling water, but not in glass vessel, that must be in a steel vessel. So what will happen? You might have seen such white colors. We call it scale. We call it scale, right? So when you are boiling the water, using a kettle, have you noticed any white particle deposited in the bottle? Just look at it. So these are all the white particles and you can see them over here, right? So what are these particles and why these particles were not visible here? Only after boiling, when water have been evaporated, only after that these particles are visible. So now point is, these white particles are commonly known as water scale. First of all, I have already told you, which consist of dissolved minerals of calcium and magnesium. So now due to these ions, your water is hard. देखिए अगर वाटर के अंदर Ca2 प्लस एंड Mg2 प्लस प्रेजेंट हैं तो इन दो आयंस की वजह से वाटर हार्ड होगा. वन मोर पॉइंट, Ca2 प्लस एंड Mg2 प्लस ऐसा नहीं हो सकता कि only cations are present. There will be or there must be anions as well. So generally the hardness will be due to Ca HCO3, CaCl2, CaSO4 or Mg HCO3 whole 2, MgCl2, MgSO4. So generally the hardness is due to these particles, right? So hardness is basically due to presence of these cations. Just remember it, if we have cations, mainly there must be anions along with them, because a solution having only cations is not possible at all. There must be anions, but I'm just telling you, if somehow you remove these anions, you remove these cations, then your water will become soft. So your water is hard only due to presence of these ions, right? And if water is having ion Na plus, then I will not call it hard water. Remember this point. So the particles, so what were these particles? What were these particles? Now I will discuss, don't worry about it. The dissolved calcium and magnesium are two of the most commonly used minerals, right? The formation of white particle is an indicator of water hardness. As water gets harder, more and more white color particles will be precipitated, right? So this is hard water, you can see this. So more and more particles will be precipitated if water is hard. So why it is unsuitable for laundry? Why we don't use hard water in the laundry? Just look at it. Hard water forms scum or precipitate with the soap. So अगर आप हार्ड वाटर को पानी में, हार्ड वाटर को आप उसके अंदर डिटर्जेंट, इफ यू ऐड डिटर्जेंट टू द हार्ड वाटर, देन व्हाट विल हैपन? Small particles, solid particles will be formed, and we call them scum or precipitate. Why they will form? Because soap containing sodium stearate, and this sodium, what is soap? Soap is basically this. Soap react with the hard water and precipitate out the calcium and magnesium stearate, right? So these are the ions which are present in the soap. When I'm saying M2 plus, so it can be Ca2 plus, it can be Mg2 plus, right? And aqueous. So on reaction you will get Ca, you will get Mg. C17H35 CO will be there. So these are precipitates, this arrow is showing you. So when you mix soap water, when you mix the soap with the hard water, so that hard water will be containing Ca2 plus ions or Mg2 plus ions, then these precipitates will be formed and we call them scum. So this is one of the way to identify the hard water. अगर आपको hard water को पहचानना है तो डिटर्जेंट डाल लीजिए, वो प्रॉपरली डिसॉल्व नहीं होगा, वो इस तरीके के पतले पतले प्रेसिपिटेट बना देगा जो उधर उधर तैरते रहेंगे, राइट. द डिसॉल्व मिनरल्स इन द वाटर प्रोवाइड अस, the dissolved minerals in the water provide us with the health preserving minerals. So point is, are these minerals important for us? Yes, they are important for us. Even our body have all these minerals. Calcium, आपने सुना होगा हम कैल्शियम की गोलियां लेते हैं, मैग्नीशियम, all these minerals are present in our body and a minimum or optimum level of calcium, magnesium, all these ions must be present. So how will that level be maintained inside our body? So when we drink water, that water will be containing these Ca2 plus ions, these Mg2 plus ions, and these will help in maintaining that level, right? Inadequate amount of intake will increase the risk of numerous health problems like kidney stone, hypertension, coronary artery disease. So hard water is also important so that we can be healthy. अगर हमें खुश रहना है, स्वस्थ रहना है, तो वाटर हार्ड पियो भाई, बहुत ज्यादा आरओ के पानी की आदत मत डालो. नेक्स्ट, the issue associated with both type of water. So let me tell you, on the other hand, excess, अगर हार्ड वाटर का एक्सेस इनटेक हो जाता है तो that will cause stress on the kidney since high concentration of mineral will be excreted through the kidney. तो अगर ये एक्सेस हो जाता है तो वो हमारी किडनीज पे एडवर्स इंपैक्ट डालेगा, किडनीज को खराब करेगा. Therefore हार्ड वाटर इज नॉट अ हेल्थ हैजर्ड. तो पूरे तरीके से हेल्थ के लिए ऐसा नहीं है कि हार्ड वाटर एक हेल्थ हैजर्ड है, बट फॉर मोस्ट ऑफ अस, हमारे लिए दिक्कत नहीं है, लेकिन जो हमारे घर में छोटे बच्चे होते हैं, हमारे घर में जो बुजुर्ग होते हैं, उनके लिए ये प्रॉब्लम क्रिएट कर सकता है, क्योंकि जो छोटे बच्चे होते हैं उनकी किडनी बहुत ही सॉफ्ट होती है, वो उसको हार्ड वाटर की जो हार्डनेस है वो उसे रिमूव करने में उसके लिए बहुत प्रॉब्लम्स होंगी, किडनी प्रॉब्लम हो सकती है. सॉफ्ट वाटर इज बेटर ऑप्शन फॉर जो बुजुर्ग हमारे घर में हैं और जो बच्चे हैं. तो हार्ड वाटर अगर कोई पूछे तो पूरे तरीके से वो नुकसानदायक नहीं है. अगर आप और हम हार्ड वाटर ले रहे हैं तो दैट इज ओके, राइट. So hard water tends to have more scale precipitate in the pipeline and other appliances. This is water scale will slowly build up and eventually clump up the pipe. तो देखिए, how will you identify the water scale? You might have seen all these. And if you are from the south, sea facing house if you have, then you must have seen all these things in your day-to-day life. So these are basically scales, right? तो क्या होगा when these scales are stuck in the pipes or in these taps? So their efficiency will be reduced and finally they will become useless. Right? Now, what is soft water? So if you remove, I just told you that water is hard. Why water is hard? Because of presence of Ca2 plus and Mg2 plus. And if you remove these impurities, then your water will become soft. So now you know what is hard water, what is soft water. So soft water will be basically the water that will contain no Ca2 plus and Mg2 plus. So soft water, water free from soluble salt of calcium and magnesium, it is called soft water. It gives the leather with the soap easily. अगर लेदर में झाग, वो साबुन के साथ आसानी से झाग बनाएगा, ये एक पहचान है सॉफ्ट वाटर को पहचानने की. हार्ड वाटर और सॉफ्ट वाटर की ये पहचान है. इट इज देयरफॉर अनसूटेबल फॉर लॉन्ड्री. एंड हार्ड वाटर, जस्ट अ मिनट. So soft water, now I have told you hard and soft water. So hard water is unsuitable for laundry. It is harmful for boilers as well as because of deposition of salt in form of scale. This reduces the efficiency of boilers. So it is harmful for the boilers. Then we have next point, types of hardness. So basically hardness is of two types, temporary hardness. we have permanent hardness. So temporary, as name suggests, you can remove the temporary hardness easily. Permanent hardness cannot be removed easily. There are many other methods which are used to remove permanent hardness. So temporary hardness. So what is temporary hardness? Now I will tell you. Temporary hardness is due to hydrogen carbonates of magnesium and calcium. And what is permanent hardness? So permanent hardness is due to chlorides of magnesium, chlorides of calcium, sulfate of magnesium and sulfate of calcium, right? So if there are hydrogen carbonates of these two cations, then I will call it permanent temporary hardness. And if hardness is due to chlorides or sulfates of magnesium and calcium, then I will call it permanently hard water. So temporary hardness is due to presence of magnesium and calcium hydrogen carbonates, and it can be removed. So there are two methods, by boiling and by Clarke method. So what will happen when we boil? What will happen when we boil? So let me tell you, if we have CaHCO3 or if we have MgHCO3 twice, so these are basically soluble salts. These are basically soluble salts. So they are dissolved. They are dissolved uniformly. When we heat up, we actually want to remove this. We actually want to remove this Ca2 plus and Mg2 plus. So right now they are dissolved. They are dissolved properly. So how we can remove them? By boiling. So I will tell you, when we boil it, during the boiling, these MgHCO3 is converted into MgOH whole twice, and CaOH3 is changed to CaCO3, and these are solid precipitates. So these precipitates can be removed by filtration. तो आपने देखा होगा घर में जब मम्मी पानी को बॉईल करती हैं तो you might have seen the white color particles. So what are those white color particles? Now I will tell you. on heating, if you are heating it, then you will get MgCO3. On heating you will get MgCO3, CO2 gas and H2O liquid. So this is precipitate. So MgCO3, of course, initially it was dissolved. But now it is not dissolved, and on heating it has converted into MgCO3 solid, and this Mg3 solid will float on the surface. Similarly, CaHCO3 on heating will give you CaCO3, H2O and CO2. So this is precipitate, and H2O liquid will be formed and CO2 will escape. So what we are doing, when we are boiling it, we are converting soluble salt into insoluble compounds, and those insoluble compounds you can easily filter them. आपने देखा होगा मम्मी एक कपड़ा लेती हैं, बॉइल्ड वाटर को उससे पास करती हैं, कपड़े के ऊपर वो व्हाइट कलर के पार्टिकल रह जाते हैं और नीचे you get the pure water, soft water, right? So what we are doing, simply by boiling them, we are converting these soluble compound into insoluble compounds. Next point, Clarke method. In this method, calculated amount of lime, so this is lime, is added to the hard water. So point number one, this is lime, but when you add it into the water, so it is basic oxide, it gets converted into CaOH whole twice, right? So 1 mole of it will give you 1 mole of it. This is called slaked lime. So in this method, calculated amount of lime is added. Now what lime will do? This lime, CaO or CaOH whole twice, will react with the MgHCO3 or CHCO3 to form insoluble compound, right? And it precipitates out the calcium carbonate and magnesium hydroxide, which can be filtered off. Just look at it. If I am taking CHCO3 plus this, on dissolving it will give you CaCO3 solid, MgCO3 solid. So these will precipitate out and you will get pure water. So finally you are removing these cations. Right? Next point is, if you have Mg2 plus, then again if you are adding it, you will get CaCO3, MgCO3 and 2H2O liquid. So again these two are precipitated and you are getting pure water free from Ca2 plus and Mg2 plus. तो हम किसी भी तरीके से Ca2 प्लस और Mg2 प्लस को निकालना चाहते हैं, पहले बॉईल करके निकाल दिया था, अब ये CaO लाइम ऐड करके निकाल दिया है. तो दिस मेथड इज कॉल्ड क्लार्क मेथड और इसके ऊपर कई बार प्रॉब्लम पूछी जा चुकी है, राइट. सो लेट्स मूव नाउ. द परमानेंट हार्डनेस, इट इज ड्यू टू प्रेजेंस ऑफ सॉल्युबल सॉल्ट of magnesium and calcium in form of chlorides and sulfates. So I have already told you, अगर कैल्शियम एंड मैग्नीशियम प्रेजेंट हैं in form of their chlorides or in form of their sulfates, then I will call it permanently hard. Why permanently hard? Because this hardness cannot be removed easily like simple boiling or using the Clarke method. To remove this particular hardness, we have to use some special methods. And what are those special methods? It can be removed by following methods. Method number one, treatment with washing soda. So what is washing soda? This is Na2CO3. Second point is Calgon's method. This method was asked in February attempt 2021. This method was asked. Next is ion exchange method or permuted method. Next one is synthetic resin method. So I'm going to take all these methods. So treatment with washing soda. So what washing soda will do? Now suppose your water is permanently hard. So you will be having CaCl2, you will be having MgCl2 or CaSO4. So washing soda react with soluble calcium and magnesium chlorides or sulfates in hard water to form insoluble. So again you are trying to convert soluble things or the soluble salts into insoluble compounds. So how that will happen? MCl2. So suppose here you are taking CaCl2 plus Na2CO3. You are going to get CaCO3 solid. It will precipitate out and you will get 2NaCl. So now just look at it. Ca2 plus, initially Ca2 plus was present. Now your solution will have Na plus and chloride, and these will not cause hardness. Hardness will be caused by Ca2 plus ions and Mg2 plus ions. I have already told you. Similarly, you can take MgCl2 or CaSO4 plus Na2CO3. So it is going to give you CaSO4 plus, sorry, CaCO3 plus Na2SO4. So again it will precipitate out and you will have Na plus ion. So Na plus ion will not cause hardness. तो आपने Mg2 plus और Ca2 plus को replace कर दिया है Na plus से. So again washing soda react with soluble calcium and magnesium chloride or sulfates, right? It can also react not with the just chloride, it can also react with the sulfates to form insoluble compound, and due to formation of this insoluble compound they will या तो ये ऊपर float करेंगे or they will settle out at the bottom place. Then you can easily filter them. Similarly MsO4 plus this, so I have already taken it, right? So next we have Calgon's method. So what is Calgon's method? It's very important. If I talk about the Calgon's method, in this method we take sodium hexametaphosphate. Very important. Many times this problem is asked, what is used in Calgon method? So this is sodium metaphosphate, and again it is water soluble, commercially called Calgon. So this is the formula of Calgon. Remember this point, very important. When I add it to hard water, the following reaction takes place. Which reaction? When you are adding this Calgon into the water, it will dissociate and will give you this, right? It will give you this. After this, what will happen? This Na, this is soluble. This is soluble. After this, M2 plus, this M2 plus can be Ca2 plus or Mg2 plus. So here I can write Ca2 plus Na4 P6O18 2 minus, and on reaction it will give you Na2 M. So this M is basically Ca. P6O18 2 minus. तो देखिए what has happened here. Look at it again. This Ca2 plus, it was causing the hardness. This have been replaced by 2 Na plus. तो अब सॉल्यूशन में 2 Na plus आ गए हैं और उनकी जगह से 2 Ca2 plus गायब हो गए, वो इस कंपाउंड का हिस्सा बन गए. तो कंपाउंड ये अभी भी सॉल्यूबल है और वाटर में ही रहेगा, लेकिन अब Ca2 plus freely available नहीं है. Ca2 plus is not available freely. So if Ca2 plus is not available freely, so now it cannot cause hardness. It will cause hardness only when Ca2 plus or Mg2 plus is available freely. So currently they are not available freely, so they cannot cause hardness. So this point is done now. So here you can write Ca2 plus, here you can write Mg2 plus. So it will finally give you Na2 Mg P6O18 2 minus plus 2Na plus. Got it? Similarly, Mg2 plus is being replaced by Na plus, and Na plus will not cause hardness. I think now you got it. So the complex anion keep the Mg2 plus and Ca2 plus ion in the solution. So Mg2 plus और C अभी भी solution में रहेंगे but independent नहीं रहेंगे. Now they are present inside this compound. Now they are present inside this compound, right? So let's move the permuted method. This method is also called zeolite or permuted process. So Calgon हमने अभी पढ़ा. Permutate is the trade name for artificially prepared sodium zeolites or sodium aluminium orthosilicate. For the sake of simplicity, the sodium aluminium silicate we write it like this way because this is SiO4 4 minus. So we are going to write Na plus, we are going to write Al3 plus. So total charge is balanced now. So for sake of simplicity, sodium aluminium silicate can be written as NaZ, right? It possesses the higher reactivity with the calcium and magnesium ion, forming the insoluble calcium and magnesium zeolite. Again, just look at it. ये जो हमने परम्यूटेट लिया है इसकी रिएक्टिविटी कैल्शियम और मैग्नीशियम के साथ बहुत हाई होने से क्या होगा, ये अपने साथ कैल्शियम और मैग्नीशियम को चिपका लेगा. यही तो हम चाहते हैं कि वाटर में जो कैल्शियम और मैग्नीशियम प्रेजेंट है ये उसे अपने साथ चिपका ले. काम खत्म. तो कैसे चिपकाएगा वो रिएक्शन में दिखा देता हूं. तो देखिए हम इसे ऐसे लिख देते हैं शॉर्ट हैंड में MaNaZ. तो देखिए यहाँ पर NaZ. तो Z बेसिकली क्या है, AlSiO4 माइनस. इस पूरे को बार बार लिखने की बजाय हमने Z लिख दिया है. तो NaZ प्लस. नाउ इफ आई राइट Mg2 प्लस, it will give you MgZ2 solid plus 2Na plus aqua. तो यहाँ Mg भी हो सकता था और यहाँ आपका Ca2 प्लस भी हो सकता था. तो दोबारा से देखिए जो हम अभी तक करते आए हैं, एवरी टाइम वी आर रिप्लेसिंग Mg विद Na प्लस. तो 2 प्लस जिनके ऊपर चार्ज है उन आयंस को हम रिप्लेस कर रहे हैं ऐसे आयन से जिनके ऊपर 1 प्लस चार्ज. सो Ca2 प्लस इज बीइंग रिप्लेस्ड बाय Na प्लस हेयर अगेन. तो Mg2 प्लस और Ca2 प्लस को रिप्लेस कर रहा है. सो दिस मेथड इज कॉल्ड परम्यूटेड और जियोलाइट मेथड. तो ये फॉर्मूला ही बड़ा इंपॉर्टेंट होता है. व्हाट इज परम्यूटेड मेथड, अगर आपको आइडिया भी होगा कि हाँ आई studied it something like this, so you can easily answer this one, right? So next is permutate or zeolite is said to be exhausted when all the sodium is used up. So we will say when all this sodium is used up, now we will say this has been exhausted and still there are Mg2 plus and Ca2 plus. Now what will we do? So it is regenerated for further use by treating with aqueous sodium chloride solution. So now we are going to add more NaCl. So this Mz2 was formed. Look at it. So this Mz2 was formed. If you are adding NaCl, it will again form NaZ. So this M is being replaced by Na plus. It is regenerated further by treating with aqueous sodium chloride solution. And Mz2 plus 2 NaCl will give you 2 NaZ and MCl2. So here again, what was M? So you can write CaZ2 solid plus 2 NaCl and it is going to give you 2 NaZ plus CaCl2. Got it? तो देखिए दोबारा से रीजनरेट हो गया है एंड अगेन ये आपकी हेल्प करेगा. किस में हेल्प करेगा? वाटर को हर सॉफ्ट बनाने में, राइट? सिंथेटिक रेजिन मेथड. ये रेजिन मेथड क्या होता है इसमें मैं आपको समझाता हूं. सपोज वी हैव दिस वाटर containing Ca containing chloride, calcium chloride we have. So you want to replace calcium as well as you want to replace chloride. So what will happen? In this case we will pass it successively. तो हम दो लेयर लेंगे, कैटायन एक्सचेंज होगी एक cation exchange resin होगा and one will be anion exchange resin, right? I'm telling you the basics of it. So what will happen? So when you will pass it through the cation exchange resin, what will happen? This cation Ca2 plus will stuck over here in form of some compound and it is being replaced by Ca plus की जगह Z plus आ जाएगा और क्लोराइड होगा. अब क्लोराइड जब एनाइन से पास होगा तो यहाँ H plus आया था तो H plus तो क्रॉस हो गया तो क्लोराइड यहाँ आकर चिपक गया किसी आयन के साथ एंड उसकी जगह वी आर गोइंग टू गेट OH माइनस. So when we will get H plus and OH, they will react and they will form pure water. So in this way we can remove Ca2 plus and C chloride. So we are replacing cation in one step, we are replacing anion in one step, and cation is replaced by H plus, anion is replaced by OH minus, and H plus and OH minus will react to form water. Got it? So water free from all soluble mineral salt is obtained by passing successively through a cation exchange resin and anion exchange resin, right? In this cation exchange resin process, H plus exchanges for Na plus, Ca2 plus or Mg2 plus and other cation present in the water. तो कोई भी cation present है उसकी जगह क्या आ जाएगा H plus. तो H plus कैसे आएगा? तो in cation exchange resin we have something RH and when you are adding Ca2 plus and chloride, this RH solid will combine with this. So I'm saying this is Ca2 plus and it will be forming CaR2 plus 2H plus. तो देखिए यहाँ पर आपका क्या था Ca2 plus था और खत्म होते होते यहाँ H plus हो गया तो H plus तो रिप्लेस हो गया लेकिन क्लोरीन अभी भी नीचे आएगा क्योंकि अभी क्लोरीन रिप्लेस नहीं हुआ है. Now chlorine will be replaced in anion exchange resin. So this process result in the proton release and thus make the water acidic. So this water will be acidic. क्यों? क्योंकि इसमें H plus आ गया है. किसकी जगह H plus आया है? In place of a cation. In place of cation we are getting H plus. So now what will happen? So in this anion exchange process we are saying RNH2. So here we will be having something RNH2. So RNH2 plus water will form RNH3 plus OH solid. This solid and X minus. So X minus can be chloride. It will be replaced by this and OH minus. So just look at it. Chloride is being replaced by OH minus. तो पहले क्लोराइड था सॉल्यूशन में और अब किससे रिप्लेस हो गया है भाई OH माइनस से. तो रिएक्शन आपको याद रखनी पड़ेंगी. तो क्लोराइड की जगह जैसे ही ये OH माइनस आपका आ जाएगा काम खत्म. तो आपको OH माइनस मिलेगा और आपको क्या मिलेगा H प्लस मिलेगा और OH मिलेगा एंड यू नो दैट H प्लस एंड OH वो दोनों रिएक्ट करके वाटर बना लेंगे एंड योर वाटर विल बी फ्री फ्रॉम Ca2 प्लस एज वेल एज क्लोराइड और सल्फेट आयंस, राइट. OH minus exchanges for anion like this and this. So it cannot, it can replace any ion, not just chloride. क्लोराइड की जगह वो भी हो सकता था हाइड्रोजन कार्बोनेट, सल्फेट भी हो सकता था. OH माइनस की उनकी सबकी जगह आ जाएगा. H प्लस और OH रिएक्ट करके वाटर बना लेंगे. The exhausted cation and anion exchange resin beds are regenerated by treatment with dilutic acid. तो ये जो खत्म होंगे उस बेड में मतलब मैं आपको दिखा देता हूँ. ये जो चीजें हैं ये एग्जॉस्ट हो जाएंगे. यू कैन अगेन रीजनरेट देम. हाउ विल यू रीजनरेट देम? by treating it with dilute acid and alkali solutions separately. So you can again regenerate those things which are causing cation or anion to precipitate, right? So this was all about the hardness of water. तो आज मैंने आपको पढ़ाया कि हार्ड वाटर क्या होता है, सॉफ्ट वाटर क्या होता है, इसे लॉन्ड्री में यूज क्यों नहीं कर सकते, ये बॉयलर्स में क्या प्रॉब्लम क्रिएट करता है, हमें हार्डनेस को कैसे निकाल सकते हैं. देयर आर टू टाइप्स ऑफ हार्डनेस, टेम्परेरी एंड परमानेंट. Temporary hardness can be removed by boiling or Clarke method. Permanent hardness, we have studied 4 methods. So revise it, follow the NCERT and I will share the module in the group, right? So just join the Tivvra group and there I will share the module and just practice it, and believe me, in 26th Feb exam evening shift, I think there were 2 questions from this topic, right? So in the next class, I'm going to take heavy water. What is heavy water? what are its properties, and uses of heavy water was asked in evening shift of 26th Feb. So just stay tuned and I will be here again with the heavy water. So guys, thank you. Bye bye. Take care. And if you really like this lecture, then please share it, like it, and click on the bell icon so that you can get my latest notification of all lectures. So thank you guys. Bye bye.